Welcome to AP Physics 1. These videos are meant to help you out in case you get stuck on any of these AP Summer Packet problems. Today we're going to be focusing on Part 4. Let's go ahead and jump right in. I'm not going to go ahead and talk about 1 yet. I really want to focus actually on number 2. Now what's going on in number 2 here is we have two parallel lines and a third transversal line. This diagonal line right here is called the transversal. And there's a couple of geometrical concepts that have to do with transversals that you should know. Namely, let's start off with the first one. If we have 30 degrees here, then the angle opposite of it right here must also be 30 degrees. And probably the most important rule is the one that follows. Right here we have alternate interior angles. Here we have the 30 degrees here must be equal to this 30 degrees here. And finally, the third one would be if this is 30 and these are on a straight line, then they must add up. So 30 degrees in theta must add up to 180, meaning that theta is equal to 150 degrees. Now, let's look at number 3. Number 3 is where the physics really kicks in. A lot of this geometry is just practice, but this one is an actual physics problem. Maybe not the question, but it's definitely a physics scenario where you have a box on an inclined plane sliding down due to gravity pulling on it against the resistance of friction. The geometry here is kind of helpful for breaking down the components of gravitational forces, but for right now, let's just focus on why is this theta equal to 30 degrees? Now, it may seem kind of complicated at first, but let's just go ahead and let's break it down here. I'm going to go ahead, I'm going to make it a little bit easier. I'm going to zoom in. All right. Okay. So, the first thing I want to point out is the fact that this left side of the incline, right over here, this left side of the incline, and this vertical line right here, these lines are parallel. Let's try that again. This line, this line is parallel with this line right here. And you can kind of view the surface of the incline as our transversal. Now, using kind of from question number 1, we can see that this is 30 and this is a right triangle. So this is 90. Then this angle up here must be 60 degrees because they all have to add up to 180. And if this is 60 and here is our transversal, let me highlight that in blue for you. All right. And so the surface of the incline being our transversal here. All right. If that's 60, that means that the opposite interior angles must be 60. So right here, this angle must be 60 degrees as well. And if this line right here is going to be perpendicular to our surface, that means we got 90, we got 60, and that means our final angle, the angle we've been trying to prove, right up here, our theta must be 30. All right. Now, I understand that was a little confusing, but there are some great videos. I'm going to link a Khan Academy video that kind of outlines this. The Khan Academy video does get into the physics and the forces, but it does a great job of kind of outlining this breakdown of angles. So if you have questions, check out that video or send me an email. I'll be happy to maybe reword this in a different way to hopefully make it a little bit more clear. Anyway, again, we will be having a quiz on this on the 3rd day of class, so let me know if you have any questions. Good luck.